All right, in this section, we'll be actually defining and computing consumer and producer surpluses. So let's first define them. Definition 5.4.3, the consumer and producer surplus. Let P0 be a fixed price for a product. The consumer surplus at the price P0 is the total amount of money saved by all consumers of this product when they pay P0 for it instead of the price that they were willing to pay. All right, so they might be willing to pay more, and that difference is what we're going to try to compute. The producer's surplus at the price P0 is the total amount of money gained by all producers of this product when they sell at the price P0 instead of the price that they were willing to sell at. Or the price at which they were willing to sell, sorry. So at which they were willing to sell. All right, so let's do an example. Again, assume that the demand function for a new phone by Mariago is 1,000 over root of x. Assume that the Mariago company sets their price at P0 equals 200. We've already computed that D16 is 250. How much would the consumer save on these 16 phones? All right, well, they were willing to pay so let's say each consumer was willing to pay at least 250, but they only pay 200. So they actually save more than this. That's a lower bound, we say, because 250 is not the exact amount that they were willing to pay. The amount they were willing to pay is 250 or more. And so each consumer saves at least 50 bucks. All right, so the 16 consumers were willing to pay at least 250. So each of them saves at least 50. So in total, they would save 16 times 50, and that's 800. But some of these consumers were willing to pay way more. In fact, because D of 4 is 500, these 4 cell phones would have sold for at least 500. So in this case, each consumer saves at least 500 minus 200, so they save at least $300. So these 4 consumers would save 4 times 300, which is $1,200. Of course, there's some overlap in these lower bounds because here, these 4 consumers are part of the ones you have here. But let's see what this means on the picture because we're after a formula for consumer and producer surplus. All right, so here's the price that's set. Sorry. Here's the price that's set. That's Y equals $200, which is P0. All right, so I want to illustrate what this actually does. This 50, what is it? This 800, what is it? So in that case, I'm looking at 16. So 16 is here. This is what I have. All right, so that's the 16 phone I'm looking at. Now we know that this point is 16,250. So we know that this height here is 50. That's the 50 that each of the consumers that we're talking about saves. And then the approximation that we're looking at, the 16 times 50, that would be this area. And so the lower bound that we found for how much consumers are saving is actually that yellow area. And that's the area that we get considering only this point of data, right? So we're ignoring how much these other consumers are saving, and we're ignoring the fact that these consumers were willing to pay way more. All right, so let's do the one from B. I still have the same equilibrium point, the equilibrium point here at 250, and I still have that lower bound of $200 that we're setting. But now we're looking at the point at 4 and at 500. All right, so we have our 4 consumers here. And now if we look at how much they save minimum, it would be that distance here. That's 500 minus 200, that's 300. That height is 300. So this rectangle here, the area of that rectangle is 4 times 300. It is the 1200 that we're computing. And so you could tell at this point that this area here will actually be the exact, that's the amount of money that everybody's saving together. We're finding rectangles that fit, and we could still add more and more rectangles here and just cover the region. But the takeaway I want you to remember here is the area between the demand function and the line y equals P0 represents the money saved by consumer. So that would be the consumer surplus.